This is a review for PC-12, exponent rules. This first problem uses the power rule, or powers to powers. And we have to remember that z is really z to the first. So we can rewrite the problem like this. It's almost like distributing the exponent, because z to the first is multiplied by 3, and x to the fourth is multiplied by 3. Our final answer is z to the third, x to the 12th. Moving to the right, this next problem uses the product rule. As long as two exponents have the same base, you keep the base and add the powers. So q stays here, and we take 4 plus 8 plus a negative 6 as our power. 4 plus 8 is 12, minus 6, q to the 6th is our final answer. This next problem is an extension of the product rule. We start with our constants, negative 3 times negative 2, and we'll multiply those. And we look at our x terms separately. So the powers are 8 and negative 9, so we will add those two together. Negative 3 times a negative 2 gives us a positive 6, and 8 plus a negative 9 gives us a negative 1. Why is this not the correct answer? Refer back to the directions at the top. Simplify each one, leaving only positive exponents. So then, how do we get rid of an exponent? Well, negative exponents in the numerator get moved to the denominator and become positive exponents. For example, this becomes 6 divided by x to the first, or just 6 divided by x. Looking at this next problem, remember that 2 is raised to the first power and p is raised to the first power. Any number or variable that does not have an exponent is actually just raised to the first power. It's invisible, like the 1 in front of p. So when we use the power rule, this becomes 2 times 1 times negative 3, p to the first power times negative 3, and q to the negative second power times negative 3. When we multiply these, we end up with 2 to the negative third, p to the negative third, and q to the positive 6. We have two different exponents that are negative. So what do? We move them to the denominator and they become positive. Q was already positive, so it stays on top, and 2 to the third is moved to the bottom, and p to the third is also moved to the bottom. And you can simplify 2 to the third because 2 times 2 times 2 is 8. So our final answer is q to the 6th divided by 8p cubed. For this next problem, we will use the quotient rule. To divide two exponents with the same base, you keep the base and subtract the powers. So negative 3 minus 4. Notice that b and c do not have the same base. So we're going to leave b to the negative 1 on top and put c to the negative third on bottom. Now, what is negative 3 minus 4? I'm going to erase and change that to a negative 7. And we can't have any negative exponents. So, the negative exponents that are already on top move down to the bottom, but the c exponent moves to the top. So they just kind of switch, and it becomes c cubed divided by a to the 7th, b. This next problem, we can start by simplifying. 8 divided by 4 just gives us 2. There is only one x, so we will leave that as x to the negative 3. Y, we can use the quotient rule, so this becomes y to the negative second minus the negative 4. If I simplify that, negative 2 plus 4, this ends up being y squared. Then I want to get rid of my negative exponent, so I change this to 2y squared divided by x cubed. For this next problem, first we're going to use the power rule and then the product rule. So this becomes x to the 4 times 4, y to the 2 times 4, x to the negative 3 times negative 7, y to the 2 times negative 7. 2 times negative 7. And that means we have x to the 16th, y to the 8th, x to the 21st, and y to the negative 14th. So I will combine the like terms and add them together. 16 plus 21, x is going to be raised to the 37th power, and y is going to be raised to the negative 6th. I can't have a negative exponent, so I change this, and it becomes x to the 37th divided by y to the 6th, using the negative exponent rule. For this next problem, let's start by simplifying our constants. 5 times 4 gives me 20 divided by a negative 8. This is not going to come out as a whole number, but I can simplify this fraction by dividing both by a 4. And I end up with 5 on top and negative 2 on bottom. And that's the simplest form I can have. So I'll start with 5x to the 4 plus 2. Since they are being multiplied, I can add those powers. And in the bottom, negative 2 times a to the 8th. The last step is to add together 4 and 2. So it's 5x to the 6th divided by negative 2a to the 8th. For the fourth section, you have to use the power rule multiple times. So 3 to the negative 3rd, x negative 6, y positive 6, 3 squared, x negative 4, y negative 6, all divided by 3x negative 2, y negative 1, all raised to the second power. I'm going to rewrite this, flipping all of the negative exponents. So any that were on the top, like 3 to the negative 3rd, I'm going to move to the bottom. And any that started off on the bottom, like x to the negative 2nd, I'm going to move to the top. And it should look like this. I have y to the 6th, 3 squared from the top. I have x squared and y to the 1st from the bottom. Then I started off with a 3 from the bottom, and I'm going to multiply this by a 3 cubed times an x to the 6th times an x to the 4th times a y to the 6th. And all of that is squared. If I clean things up a little bit by simplifying 2 minus 10, I see I have a negative 8. And for y, 7 minus 6, I have a positive 1. That tells me where those go. 9 and 81 can both be divided by 9. And then the last step is to distribute this last power, the 2. In this final problem, this entire section is raised to the power of 0, and according to the 0 exponent rule, this becomes a 1. So 1 times anything is going to be itself. We can just cross it off. If we use the power rule, we have 7 to the negative 4th, y to the positive 20, z to the negative 28, divided by 21, y to the negative 2nd, z to the negative 5th, all of this raised to the negative 4th. There's a couple pathways you can take from here. I'm going to move all the negative exponents, which means I will have y to the 20th, I will have y squared, and z to the 5th on top. These two moved up. Then for the bottom, I'm going to start with 21. I'm going to add 7 to the 4th and z to the 28th. These two move down because of the negative exponents. And this whole thing is raised to the negative 4th. If I simplify things a little bit further by adding together the 20 and the 2 and multiplying 21 times 7 to the 4th to get that, I can now simplify z. And this is my final answer.